Okay, everybody, then we move on a little bit to another part of the quantitative part of solutions. And this has to do with measuring something called concentration and actually measuring it. In this case, we're not just making, some solution by just dumping any amount of solute into any amount of solute. We're actually looking at a specific amount of solute in a specific amount of solution. So the first way we can measure concentration, there are many different ways to express mathematically how much solute you're putting in a solution, or relative to any type of the mixture, is something called molarity. And deep inside that word, you see the word. You can see it inside here. You see the word mole. All right, so we can express the amount of solute in a solution by looking at something called a molarity. All right, and molarity is basically an expression used by mostly by chemists, which relates the number of moles, okay, how many moles of the solute you have, to the number of liters of the total solution. That's really important to know, that the liters of total solution actually includes, okay, the solute. Okay, so you're assuming the solute is already dissolved in the solution, so that the volume is the complete solution. Okay, and the units for this, of course, is moles per liter. Okay, or sometimes they use the big M as the symbol for molarity, and sometimes we call that a molar solution. Okay, a 1.0 molar solution then therefore has 1 mole of a solute. Notice it does not specify how many grams you have. We're looking at the expression of how many particles are dissolved in a liter of total solution. It does not specify the mass. So this is going to be specific for every solute, because each solute, of course, has a certain amount of mass for that mole. So again, this implies using part of the GFM. Okay, often this is used to calculate chemical quantities for reactions that take place in solutions. Okay, so if you were to visualize, have a liter, okay, and you had a liter of total solution, you had 1 mole in that, that would be 1 mole divided by 1 liter, 1 mole per liter, or a 1 molar solution would be 1 mole of solute per liter of solution. Now what we can do is, so really the formula becomes molarity is moles over liters, okay? Solute over solution. Okay, what I think it's useful to do is to put the molarity over 1 here, so that you can cross multiply just in case you're missing one of these particular variables. The only problem with the formula, again, this is a very specific formula. You have to be in moles and you have to be in liters. So guess what you have to do is you're going to have to be able to convert. All right, so if you have to convert between grams and moles, we want to recall how we're going to go from grams to moles and moles to grams. Again, grams, okay, in order to go from grams to moles, you're going to divide by the GFM, right? So divide by GFM. And when you want to go from moles to grams, you're going to multiply by the GFM. Okay, remember, you're going in out of the moles. So dividing by the GFM gets you into moles. Multiplying by the GFM gets you back into grams. Okay, same thing with this. Again, 1 liter is equal to 1,000 milliliters. Okay, so if you want to go back and forth, if you're going to go in and out of the liter, if you're going into the liter, you're going to take, you're going to divide by 1,000, right? So you're going to divide by 1,000 here. Okay, you're going to multiply by 1,000 here. All right, so important to know if you're going to get to milliliters. Again, this will get you to milliliters here. All right, so you have to be able to get to these things. Now, often problems will not ask you not to do that. They'll actually just ask you the question. You're going to have to be involved in making that distinction. So it comes up with practice. Just to get a feel for molarity, just get a feel for the numbers. Let's just say you had 3 solutions, and they were all at 1 liter. Again, the line is 1 liter, so the bottom number stays the same here. So this is 1 liter, and you would have 3 moles, 6 moles, and 12 moles. Again, the higher that molarity, the more concentrated that solution gets, right? So the sweeter it gets, so or the more thicker it gets, or the more concentrated with solute you get, the stronger it gets. You could think about that. So if this was acid, the more concentrated acid would be 12 moles, 6 moles, and you get more diluted as you go that way. You can think about this way being, dilution is going in that direction. So that's important to know. The feeling for molarity. The higher the number, again, the more concentrated you get, so you get an idea when you see that number. All right. How you make a molar solution is going to become important. So how you make this is big. So a lot of times chemists make molar solutions in the lab, and they want to be pretty specific sometimes on this. Okay. So what we'll see is this thing called a volumetric flask. Okay. Now a volumetric flask has this strange shape to it, and it's got a marker that is engraved right at the neck of this. Okay, now again, if you're making a 1 molar solution, let's just say I'm making a 1 molar solution, I want to make sure that actually, let's just say this is a liter flask, a liter flask, a liter flask. This is all the same thing, just going in this direction. That the line on here is 1 liter. Now, if you're making a molar solution, you want to make sure that the solute and the solvent both fit in the liter. Right? So it's important to know that you don't want to add your solvent all the way to the top and then add the solute, because then you'll go over the liter, right? You'll have some volume increase. We all know that, you have water displacement, you have a volume increase when you add things. So you want to make sure you follow these specific steps. Okay, if you're going to make a molar solution, okay, you're going to make some type of solution, whether it's a molar or 2 moles, whatever it happens to be, you're going to always add the exact number of grams or moles of your compound to a volumetric flask. So here, you're going to add that first. Always add your solute to there first, how much you need for that moles. Okay, number 2, you're going to add a small amount of your solvent. Okay, and just enough so that you can dissolve it. So notice that, we're adding the solute first. We're adding a little bit of solvent to dissolve it. Make sure you're getting that solution that's completely dissolved in letter B, okay? And then you're going to swirl it, and you'll dissolve it. Make sure you mix it really good to dissolve. You want to make sure you have some room to stir that around. Okay, and 4, then you want to add the remaining solvent, okay? And then you're going to add the remaining solvent so that you fill this up to the line to exactly that 1 liter, okay? And then you would have your 1 mole per 1 liter. Again, if you add the liter and then add the mole, then this number might be higher than 1 liter, and then you wouldn't be making the 1 molar solution. All right, so it's really important to follow these steps in this order. Again, you'll have questions on this, and they will ask you on a test how to actually make a molar solution. If you're confused by this, you can rewind it, or you can bring those questions to class, and we can actually see it. Okay, so let's just do a molarity problem and see how this goes, and see how we can get used to doing the math on this. Okay, so what is a molarity of 37 grams of calcium hydroxide is dissolved in 750 total solution? All right, so they're asking you for the molarity. So again, what is the molarity? What I would always do is say, okay, molarity, okay, over 1 is my moles over liters, right? So that's always true. Now let's just see. Now in this example, let's see what we're given. We're given 37 grams of calcium hydroxide, and we're given 750 milliliters of total solution. Okay, so we have 2 numbers. We're asking to find the molarity. So really, X over 1, right? X molarity over 1 is going to be the moles over liters. And the problem with this is that we don't have moles and we don't have liters. So step 1 is going to be get into moles. So step 1, we're going to have to take 37 grams, and we're going to have to divide it by the GFM of calcium hydroxide, which is 74 grams per mole. So I'm doing it really quickly here. So 74 grams per mole, that's going to give me a nice round number of 0.5 moles. Okay, and number 2, we were looking for liters. We don't have liters. So we're going to take 750 milliliters. We're going to divide it by 1,000 milliliters per liter. Okay, and we're going to get 0.75 liters. Okay, now that we're ready with those 2 numbers, we're ready to take the moles and the liters and put it in the equation. Okay, so molarity is going to be equal to 0.5 moles, okay, over 0.75 liters. Okay, and my answer is going to be, if we do that the right way, we take 0.5 divided by 0.75, and so we simply get 0.67 big M. Okay, or you could say moles per liter. Either way is good. Big M is what you usually see. All right, so very simple. Again, you got to do those conversions, and you got to know how to do them quickly, and you got to be ready for it. So again, it takes practice. So we'll move on. We'll practice a few more here. Okay, it gets, and then again, I'll do maybe a first couple of them with you, and then I'll let you do them on your own. I'll give you the answers to them so you can follow along. All right, so we'll go back. All right, so then we have, go back to my yellow page. Okay, and the next one. So the first one says, this one here says is about 1 gram. Okay, you're given 1 gram of calcium ions and 1 liter of milk. That's the thing you're given. Okay, I like to box off what I'm asked. I'm asked the molarity of my solute, which is my calcium ions. Okay, and the fact that it's an ion really doesn't matter. Again, we talked about electrons weighing almost nothing, so we're going to assume calcium is just regular calcium. Okay, and again, what do? We take molarity equals moles over liters. I would always write the equation. Okay, and in this case, again, we're given a liter, which is fine. We're given the liter down here, but we're not given moles. So step one is we want to find the moles. So we're going to take 1 gram of calcium, okay, and we'll divide it by the GFM of calcium, dividing into the mole by 40, okay, and we're going to get 0.025 moles, okay, of calcium 2 plus. All right. Now, what's nice about this is that they're asking for molarity, and they gave you the liters. So you do have liters. You have the bottom number. That's perfect. So we can say molarity equals, or over 1, it's fine, is going to now equal 0.025 moles over 1 liter. So that becomes your molarity, 0.025 big M. That's your answer. Okay, easy stuff, guys. Not a big deal, right? All right, so we can work backwards a little bit. Okay, we can work backwards a little bit in number 2, and I'll just show you this, and I'll let you do 3 and 4 on your own. But if we do this, this says now how many moles of this. Okay, so we're looking for the moles. So if I look at, and what am I given? I'm given liters, and I'm given the molarity. All right, so if I look at my formula, molarity over 1 equals moles over liters. If I look at it that way. Okay, and let's just see, do I have, now again, I'm looking for moles. I do have liters, which matches my equation, and I'm given molarity, which matches my equation. So this is really molarity over 1 is going to be X over liters. Okay, so if I just rearrange my formula, I could do it that way. Okay, or I could just leave it. I could just plug my numbers in and say, okay, 1.6 liters over 1 is now equal to X over, oh, I'm sorry, I could, that's actually wrong. Let's do it the different way. I messed up. All right, yeah, following the formula, I can do 0.54 molarity, there we go, over 1 equals X over 1.63. That's why we got to get ourselves right here, liters. Okay, so really X is, if you cross multiply, X would equal 0.954 times 1.63, right? So the moles always equal that. So now X moles, so X is now going to equal, if I take my 0.954 and I times it by 1.63, I'm going to equal about 1.56. 1.56. Now what's my moles? That's what I'm looking for. Moles, okay, of H2SO4. Now, really important, if I have my moles of H2SO4 and the question should ask you for grams, that's going to be easy to do, right? Because then I can multiply out by my GFM, okay? So look for those. Again, that's what you're going to do in number 3 here, and number 4 asks you for volumes. Now, that example for number 3, the answer here I'm going to give you is going to be 61.7 grams. That's going to be my answer. Confirm that you can do this, okay? And my answer to number 4 here is going to be 1.16 liters. And again, as usual, if you're a little bit off from my answers because of rounding, you'll probably be okay. All right? So if any problems, again, bring your questions to class. I urge you to do that. Again, molarity becomes one of those, I'm not really too sure why, but molarity can be a little bit confusing when they ask you for different things within the formula. So just, again, make sure you practice, and again, stay in it, and bring your questions to class. Have a wonderful day.